We all know the image. A stooped, knuckle-dragging ape slowly stands up, sheds its body hair, and walks confidently to the right as a modern human. It is the most famous illustration of human evolution ever created. It is also a scientific myth. Evolution does not operate on a straight, predictable track. It is a messy, branching process. This timeline shows our actual ancestry. Over the last 6 million years, dozens of different hominid species emerged. Some lived at the same time in the same regions. Many others hit evolutionary dead ends and vanished. If our history lacks a clean, ladder-like progression, how did one single lineage outlast all the others to dominate the planet? To find the answer, we have to trace the specific anatomical shifts that gave our ancestors advantages over the rest of our extinct family tree. The earliest branches of our tree include species like Sahelanthropus and Ardipithecus. Living between 6 and 4 million years ago, they began to show signs of walking upright, though they still spent much of their lives in the trees. By 4 million years ago, a new genus appeared, Australopithecus. The most famous specimen from this group, known as Lucy, roamed East Africa and adopted full bipedalism. You can see the evidence of this upright walking directly in the fossil record. The structure of Lucy's pelvis and leg bones proves she walked on 2 feet, even though her brain was still roughly the size of a modern chimpanzee's. By standing up, these hominids permanently freed their hands. They could now carry food, hold offspring, and manipulate the world around them. Roughly 2.4 million years ago, those free hands were put to work by a new species, Homo habilis, often called the handyman. They were the first to consistently manufacture tools. By striking rocks together, they produced sharp Oldowan stone flakes. With these sharp edges, early hominids could slice through tough hides and crack open bones for marrow. This provided access to high-calorie fats that were previously unreachable. By 1.9 million years ago, Homo erectus arrived. They were the first hominids to display modern body proportions, longer legs for endurance running, and shorter arms. They were also the first to harness fire. They could cook food, stay warm in cold environments, and ward off predators. Armed with stone blades and fire, Homo erectus successfully migrated out of Africa and established populations across several continents. While our direct ancestors continued to evolve, other branches thrived in parallel. Between 400,000 and 40,000 years ago, Neanderthals lived alongside early humans. They were adapted to the cold of Ice Age Europe, possessing a shorter, stockier build that effectively conserved body heat. They were intelligent enough to wear clothing, engage in symbolic thought, and deliberately bury their dead. Neanderthals possessed advanced culture and robust survival skills, yet they disappeared while our lineage remained. Modern Homo sapiens emerged in Africa roughly 300,000 years ago. Physically, we had a lighter skeletal build, a vertical forehead, and a prominent chin. This diagram compares cranial capacity. Through encephalization, our brain size increased relative to body mass, averaging 1,300 cubic centimeters. Inside, developing Broca's area and the hyoid bone gave us the physical mechanics for complex language. Language allowed early humans to share abstract ideas, coordinate large groups, and pass down strategic plans across generations. With this cognitive advantage, Homo sapiens initiated a major migration out of Africa between 60,000 and 90,000 years ago. As they expanded into Europe and Asia, they collided with other hominins. Over millennia, early humans interbred with and eventually replaced populations like the Neanderthals and the Denisovans. Our success was built on a series of overlapping capabilities: walking upright, manufacturing tools, mastering fire, and communicating through language. Each trait provided a new layer of resilience. We are not the inevitable result of a straight line of progress. We are simply the last remaining leaf on a deeply pruned family tree.